Hello guys, and welcome back to another video. Now sorry it's been a little while since my last video. As I mentioned on Instagram, I have had quite a lot going on recently, but I'm back at it and back making more videos. So in this one, you might have seen this before, probably when you learn about trigonometry at GCSE maths level. This formula here. So how to find the area of any triangle? Well, it's a half times 2 of the sides, AB, times sine of the other angle. And by the other angle, I mean the angle of the side that we haven't included. So let me draw a picture to show you what I mean. So let's take any old triangle. Okay. This can be A, this can be B, this can be C, and then we have the angles. So usually across from side A we have angle capital A, across from side B we have angle capital B, and across from side C we have angle capital C. Okay, so this would be our triangle. Then the area would be this side times times a half times sine of this angle here. Okay, so what we're going to do today is prove this formula. Now it's very simple. The only things we really need to know is standard bit of trigonometry, which is SOHCAHTOA. And I've done quite a few videos on this, but I will write them out again. So these are just definitions you need to know. Sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And the tangent of the angle theta equals the opposite over the adjacent. Okay. What else do we need to prove this? Well, we need that the area of a triangle is also a half times the base times the height. Okay, and this is a really standard result. So area of any triangle is a half times the base times the height. So you might be thinking, well, why on earth do we actually need this formula then, if we've got this formula here? We know how to find the area of any triangle. It's just a half base times height. But what if we have a triangle like this and we don't know what the height is? So that's why it's really useful to have this formula. Right, let's get into the proof. Now, the first thing we're going to do is quite a standard trick in these geometry and trig problems. You drop a perpendicular line. So starting from this here, we are going to drop a perpendicular line. And by that term dropping a perpendicular, what I mean is it's perpendicular to the base, A. And we're going to call this line H for the height. So H is perpendicular to A. Okay, and remember what this term perpendicular means? It means the two lines meet at 90 degrees. Or meet at a 90-degree angle. Okay, so we're actually sort of almost there. Now we're just going to use some trigonometry to find H in terms of B, C, and A. Okay, so let's now take a look at this angle C here, which I've highlighted, and let's try and express the angle C as one of these trig ratios here. So we're going to have either sine, cosine, or tangent of C. And let's look at H and B. Now, what are H and B in relation to C? Well, H is the opposite, and B is the hypotenuse. So that's O and H. That tells us we're going to use sine. Okay, so writing this out, we have sine of the angle C, that's big C, equals the opposite, which is H, and the hypotenuse, which is B. Okay, so in other words, I'll go this way, we have H equals B sine C. Now, hopefully you can see what I'm going to do next. What we're going to do is just use this formula here and apply it to our triangle. So we're going to get the area of our triangle is just equal to a half times the base, well the base in this case is A, that's here, and times the height, well the height is H. But we also know from this formula that H is B sine C. So let's plug that in here. So we're just replacing H by B sine C. So we've got half times A times B sine C. And simplifying this up, we do get a half A B sine C as required. So there we go, guys. We have now proved that the area of any triangle is this thing here, a half AB sine C. I really hope you enjoyed. Please hit that like button if you want to see more videos. And yeah, thanks for watching. Leave a comment if you enjoyed as well. Have a nice day. See you later.